Second video of the week. This will be homework for the weekend. Please make sure you have your pink fill-in-the-blanks note sheet for Chapter 2, Section 3. And it'll run just like it did the other day in the Chromebook lab if you were there. Find the video on Schoology under File and Link. Fill out the notes during the video. And then there will be a short quiz on Schoology under, I believe, Quizzes and Tests for Chapter 2, Section 3. Chemical properties of matter. Chapter 2-3, chemical properties. Chemical properties describe matter based on its ability to change into new matter that has different properties than it originally started with. Examples include flammability, which is the ability of a substance to burn. When wood burns, it can turn into smoke and ashes, which have different chemical properties than when it started out as wood. Number 2, reactivity, the ability of two or more substances to combine and form one or more new substances, such as an old car or some metal chunk sitting outside. The iron in the old car left outside can form rust when it is exposed to oxygen. And number 3, the pH of a substance, which means the measure of the acidity or basicity of a substance. I think you guys have learned this before, but it's measured on a scale from 0 to 14. And there's an example there that shows you common items with vinegar way over here, apples, lemon juice, battery acid, which is very strong. The closer you get to 0, the stronger the acid. As we work away from that, toward the middle, 7 is neutral, and 14 is a base. So we're moving from strong acid, weaker acid, to neutral, weak base, stronger base, all the way to a very strong base. So a pH lower than 7 means it's an acid. A pH higher than 7 means it's a base, and right at 7 means it is neutral. A chemical change occurs when one substance changes its identity into new substance. Chemical changes occur because chemical reactions have taken place. Something chemically has changed to turn that original substance, when it was combined with something, into a totally new substance. Examples: burning a piece of paper shows a chemical reaction. Vinegar and baking soda bubble up due to the reaction of an acid and a base. Sour milk, because bacteria have formed new substances in that milk. And I'm sure a few of you guys have tried that before, just when you want to get a nice big bowl of cereal and the milk is sour. If you guys know who that is, you get a bonus point. Just kidding. I think some of you know who that is. Another example is a battery creating an electrical charge. Whether it's a boat battery, a snowmobile battery, a car battery, a truck, a bus, that battery generates an electrical charge. When our body digests food, now not the chewing part, that's physically tearing apart the food, but chemically down in the stomach and the intestines and the rest of the digestive processes involves a chemical reaction. And then finally, another rusty item outside, this old mailbox. Now, there are some common signs that show a chemical change has occurred. Sometimes when you see these signs out in nature or in a lab or doing an experiment, you know for a fact that a chemical change has occurred just by observing it. A change in temperature, either producing heat or absorbing heat, which means it turns cold. A change in color. A lot of times you'll notice substances change color when mixed, which usually indicates a chemical reaction. And finally, when something is combined, oftentimes it can produce a solid particle or actually give off a gas. That's generally a sign that there is a chemical change that's occurred. Now, can physical and chemical changes both be reversed? Let's check that out. Many physical changes are easily reversed. For example, you have water, we freeze it into cubes or ice chunks, and you can thaw it back out again into water. Now that's a physical change from a state of matter, from a liquid to solid and back to a liquid. That is very easily reversed. However, most chemical changes cannot be reversed. Let's say it's a nice campfire in the summertime. You're roasting marshmallows and hot dogs, telling stories. Now, when that fire's out, you're going to have ashes. So after burning a piece of wood, the ashes cannot be made back into a piece of wood. They're simply ashes. They can't change back into what it originally was, a log or a piece of wood from a tree.